All right, let's see here. Spencer, what did you say was an animal?
I said a bird.
Correct. Mammal, correct. I think it's just a bird and a mammal, right? Unless it's like a transformer, then the car could be a. But it's we're not going there. We're not going there. All right, Daniel, what'd you say is a vehicle? Agreed. Agree. Disagree. But all right, now I'll finish this last one here. I think an apartment is a dwelling and a house is a dwelling, and technically some people live out of their cars, not to judge. Some people take buses and turn them into houses. But I'm going to say an apartment and a house are dwellings there. All right, so why are we doing this? Well, it says when creating classes, it's helpful to organize objects with similar properties according to how they are related. If objects have common attributes and common behaviors, it's helpful to group them to share these attributes and objects. Behaviors. For instance, a shape class could be written having perimeter and area attributes with the need to calculate their perimeter and area. Methods. If you wanted objects classes for square and triangle, it would be helpful to let the square and triangle classes share the things from the shape class because they are shapes. We can write these relationships in what is called an is a relationship. A square is a shape. A triangle is a shape. Annie, what did you put for number 1 here? Apartment is a dwelling. I agree. Let's see here. What are some attributes, some instance variables you could use to describe the column A item? So let's go with what Annie said. Annie said dwelling for the column A thing, which the column B items could share. So what does a dwelling have in general that an apartment also has? Yeah, Daniel. Square footage, I think, is perfect. No matter what the dwelling is, whether it's an apartment, a house, whatever, square footage. What else? Yeah, Sam. Provide cover, you said? Provide shelter. Yeah. How about like I don't know if you've ever bought a house, probably not. Maybe your parents have. Like number of bathrooms, number of bedrooms. Every dwelling might have a monetary value, a price. It might have a number of floors, number of couches. Yeah, Annie? A location would be perfect. Yeah. All of that stuff. I like that location one. Zillow. One time I looked at one thing on Zillow and I still get emails and they just don't die. I report spam every time and just they spread. The virus is spreading. Any other ones you want to add? 3, what are some actions or methods? So we got to kind of think about classes for a second because some of us haven't written classes in a while. Remember, you've got instance variables, your attributes, and you've got actions, your verbs, your methods. What can it do? What can your column A, our dwelling item, do that could be computed about your column B item, which could be shared by your column B items? Daniel, you got an idea? Price per square foot. So using these variables up here, what could we calculate down here? Well, Sam, you got something?
I was going to say, the value of the house.
Yeah, sure. Yeah, like using the value, maybe using if we said value was not up here, then we could probably put calculating the value down here, something like that. You could probably calculate the value based on the square footage, number of bathrooms, number of bedrooms, the location. What do real estate agents always say? It's all about location, location, location. Yeah, Sam, go ahead. How many people it can house? Number of people supported or something? kind of. Anything else? Yeah, Eli.
Couches per square foot.
Couches now, okay. Couches per square foot, we could calculate that. Using this up here, we could do all kinds of stuff. Say it again? Okay. It's probably best. It says these relationships are described as inheritance. We name the column A items as a superclass and the column B items as a subclass. We say that a subclass extends a superclass and therefore inherits the instance variable and methods of the superclass. Okay, this is very important. It's an organizational thing that we are going to start to understand, and I think you guys might have a good foundation about it already, especially if you've taken biology. Is anybody in here taking biology? Okay, a couple of you. Okay, good. So, what's the, I don't remember how it goes, like genus, kingdom, spaghetti? Wait, can you say them again so I can put them in the microphone? King. Okay, but what does Phil, okay, so kingdom, phylum, class, order, genus, species. So everything that's in the same kingdom, it's always gotta remember family. Family comes first. So everything that's in the same kingdom has a couple things in common, right? And then what's the next one? Everything that's in the same phylum has a little bit more specific, has some things in common. What's next? Class, everything that, oh, that's confusing for this. Everything that's in the same class has more things in common. What's next? Order, everything in the same order has more things in common. It's kind of augmented. It gets more specific. What's next? Family. So everything in the same family has some stuff in common. Genus. Everything in the same genus has some stuff in common. Is there one more? Species. Everything in the same, well, wait. I guess there's only a that's the last level, right? So species is a, so how could we do this, biology people? What's right above species again? Family? Genus. So what's like a genus example? Other than me, I'm a oh wait, that's different. Homo. Okay, so homo so everything that's in the homo genus has some stuff in common, right? Like what can the homos all do? Can they walk? Oh, grow up out there. Grow up. I hear you. Oh, the internet comments are going to be... Can they all walk? They can all mobilize. They can all move. They're bipedal. Thank you, Ben. They're all bipedal. They can all walk. Homo can walk. Okay, they're bipedal. Okay, so everything that's part of homo can walk on 2 feet, essentially. All right. Okay. So we say that a subclass extends a superclass and therefore inherits the instance variables. Give me 1 second. Inheritance, day 1. I feel for you, Daniel. One of the really useful features of object-oriented programming is inheritance. You may have heard of someone coming into an inheritance, which often means they were left something from a relative who died. Oh. Or you might hear someone say that they have inherited musical ability from a parent. What stuff have you guys inherited from your parents? Maybe you don't notice it yet. Okay, Gino, but like, do you ever notice you do stuff very similar to your parents? I twitch? Oh my gosh. My dad does this thing when he's annoyed where he kind of blinks his eyes like this, and I do it all the time. You might not notice how much you are like your parents until you're like 30, and then you look in the mirror and you go, oh my god. I know, more revealing details. Okay. You might hear someone say that they've inherited musical ability from a parent. In Java, all classes can inherit attributes, which are instance variables, and behaviors from another class. So I'm going to write that down. I'm going to say inheritance. Classes can inherit instance variables and methods from other classes. So, for example, all mammals, let's be very careful here, all mammals give milk. Give milk. Now, they do it in different ways, but all mammals do give milk. And so I can say the mammal class, one of their abilities is give milk. And what's something that's a subclass of mammal? I don't know. Primates are maybe subclasses of mammal. Dogs, whatever. They can all give milk as well. So that would be an example of inheriting a method from another class, where mammal would be the superclass, and then a dog is a mammal, a human is a mammal, a primate is a mammal, etc., which means they can all give milk. Okay. Let's see here. The class being inherited from is called the parent class or the superclass. The class that is inheriting is called the child class or subclass. Okay, I'm going to write that down as well. So, parent class. What did it say? Parent slash superclass? This is the class being inherited from. I'm going to write from in a different color because it's important to note the distinction between this here. This is the class being inherited from, like mammal, for example, would be a parent class or a superclass. And then there's also the child class or subclass. That's the one that is inheriting. The class. How can I make that? How can I say this? Why did it delete everything? Child, sub, class. The class. How do I say it? Being inherited to? You know what I mean? Doing the inheriting. The class that inherits. Thank you. I'm going to write that. That inherits. So, for example, your parents are like a parent class. You get maybe your eye color from them. Maybe you get your hair color from them. Maybe you get your build. Some people say your athleticism, your musical ability, your intellectual ability. Unfortunately for me, your sense of humor. Stuff like that. Oh. Dad, I love you if you're listening. Anyway, you can inherit that stuff. If you're the child, you can inherit that stuff. Okay. I know nobody listens to these. All right. When one class inherits from another, we can say that is the same kind of thing as the parent class. The class that inherits from. For example, a car is a kind of vehicle. This is sometimes called the is a relationship, but more accurately, it's a is a kind of relationship. A motorcycle is another kind of vehicle. All vehicles have a make, model, and year that they were created. All vehicles can go forward, backward, turn left, and turn right. So, the last thing I want to write down right now is this is a relationship. The is a relationship. Basically means would I say parent is a child or child is a parent in this relationship here? Or would I say super is a sub or sub is a super? Sub is a super. Sub is a super. Or in other words, dog is a mammal. Dog would be the subclass, mammal would be the superclass. Sub is a super. That's the is a relationship. I've got a slide demonstrating kind of what's going on here. Inheritance allows a software developer to derive a new class from an existing one. So a parent class or a super class, or sometimes you call it a base class, and then you've got a child class or a subclass. Sometimes you might call it a derived class. You're getting that class from another class. The child class inherits the methods and data defined for the parent class. To tailor a derived class, the programmer can add new variables or methods or can modify the inherited ones. So you can kind of augment a class. For example, if you say dog is a mammal, yes, a dog must give milk because it's a mammal, but then a dog could also bark. You would agree that not all mammals bark. A dog might also, what's very specific to a dog but not all mammals? Stick their tongue out. They might go to the bathroom on a fire hydrant. Those are things that are hopefully particular to dogs as mammals, and not all hopefully not all mammals. Inheritance should create an is-a relationship, meaning the child is a more specific version of the parent. I'm going to write that down. I think that's important. The child is a more specific version of the parent. A dog is a more specific version of a mammal, etc. If you have an athlete class, you could make a swimmer a subclass of athlete. A swimmer is a more specific version of an athlete. You could have a card game class, and solitaire could be a subclass of card game. Is this start kind of clicking a little bit? Making a little bit sense? Okay. Just kind of dipping our toe into the water, getting our beaks wet here with some inheritance. All right. I'm not going to talk a ton about these diagrams, but it's called the UML diagram. It just basically shows what classes inherit from others using arrows. This is saying vehicle is the parent class, and car is a vehicle, motor is a vehicle, which means a car is going to have a make, model, and year. A motorcycle will have a make, model, and year. A car can go forward, backward, turn left, and turn right, and so can a motorcycle. They inherit those capabilities from the vehicle class. That kind of makes sense? Okay. These diagrams are rarely used, but, well, in the industry they're used more often. Here in the AP class, we don't use them that often. All right, 2. Okay, now we actually get into some code. Now that we've talked about what it means to inherit or extend, to actually make it extend, you say subclass extends superclass. To make a subclass inherit from a superclass, use the Java keyword extends with the superclass name when creating a new subclass as shown below. Public class car extends vehicle. Public class motorcycle extends vehicle. While a person can have 2 parents, a Java class can only inherit from one class. So I'm going to write down here basically how to inherit is I think what I'll call this. How to inherit. So I'm going to say basically in class header use keyword extends. So in general, you would say something like public class child extends whatever the name of the parent class is. Let's make it more specific using the warm-up activity we did. On the warm-up activity we had, let's see here. What did we say? Apartment is a dwelling? Annie, is that what you told? Like, what did you say number 1 again? Apartment is a dwelling. So I could say something like public class apartment. That's the name of the child class. That's the name of the class you would be writing with this class header. Extends dwelling. So in general, in the class header, you say public class, whatever the name of the child class you're currently writing is, extends parent. Public class rectangle extends shape. Public class apartment extends dwelling. Public class dog extends mammal. Public class Homo sapien extends homo. Yes, Daniel.
Can we have extensions of the function? Like squares or rectangles?
Yes. Now, the way that would work is you would have the very base class public class shape. Then you would have public class rectangle extends shape. And then you would have public class square extends rectangle. But what I can't, so I can only inherit from one thing, so I should probably write that down here. That's very important. A class can only extend one class. However, if a square is a rectangle, that means that a square is also a shape. Because square extends rectangle, rectangle extends shape. A square is a square is a rectangle, a square is a shape. Does that make sense? Ian, did you want to add something? Or a question? What I just said. I said a good thing? There is a first time for everything. Yes?
So when you're actually writing it, do you write it under the class or is it just if you save it, save?
So they'll be in two different files still. Is that what you're kind of asking? So like public class shape would be in its own Java file, and then public class rectangle would be in its own Java file.
You just save it to the save?
Right, but anything that's public inside of the shape class, I don't need to write again inside of the rectangle class. It just inherits it, it just gets it. So it says when a person can have two parents, a Java class can only inherit from one parent class. If you leave off the extends keyword when you declare class, then the class will inherit from the object class. Whoa! So if I just say public class shape, what's going on in the background is Java's kind of whispering extends object. So every class we've made, we've actually been doing inheritance since the third day of Computer Science 1. You just didn't know it. Anytime we said public class anything, it was extending object. It's just implicitly extending object. Do you remember how if we didn't write a toString method, we got something weird when we tried to print out an object? Here's why. We were extending the object class without you knowing it, so guess where we got our toString method from? The object class. We inherited it without you even knowing. What does the toString method look like for the object class? Well, it says the name of the class, at, and then some weird hexadecimal characters, numbers, and letters and stuff like that. But that was, we've been doing a little bit of inheritance behind the scenes we didn't even know. Okay. I should write that down. All classes, by default, extend object. If no explicit extends mentioned, implicitly extends object. Now, that doesn't mean a ton for us, but there are two methods that are in object that you inherit that usually you want to write over. One of them is toString. The other one we inherit from object is dot equals. The dot equals method for an object just compares the memory address. That's why we usually want to write our own dot equals method so we don't use the one that we inherit. You can augment a class that you inherit by changing it, writing over some of the methods. Okay, moving on. Why use inherit? Is this the last section? Perfect timing. Somebody knock? Oh, thanks, Daniel. It says, why use inheritance? Hey, Drew, you can just set everything right over there. Why use inheritance? Inheritance allows you to reuse data and behavior from the parent class. If you notice that several classes share the same data and or behavior, you can pull that out into a parent class. This is called generalization. For example, customers and employees are both people, so it makes sense to use the general person class as seen below. Inheritance is also useful for specialization, which is when you want most of the behavior of a parent class but want to do at least one thing differently and or add more data. The example below can also be seen as a specialization. An employee is a person but also has a unique ID. A customer is a person, but also has a credit card. What if we did one more here? Let's say we do one more inheritance of a student class. You would agree that a student has a name and address, right? That's generalization. If I want to specialize now, what's some data that's specific to a student that a person in general does not have? What? Classes. Okay, so I thought you said glasses. I was like, people can have those, though. There's just adults walking around blind. GPA, student ID, stuff like that. People in general don't have those. Students generally have a name and address, but students are specialized because they have classes, which maybe, Ben, I would say that's probably a 1D array of, not listening, 1D array of strings. That's the class name. Or a double for GPA or an int for student ID. Actually, yours is a string because doesn't it start with some letter? No, it's just numbers. Okay, never mind. All right, some questions here. Let's do them together. 911. If you don't specify the parent class in a class declaration, which of the following is true? A, it doesn't have a parent class. Is that true? No. B, it inherits from the object class. Is that true? Yeah, B should be the answer there. Next question, it says, if the class vehicle has this just means instance variables, instance fields make and model, and the class car inherits from the class vehicle, will a car object have a make and model? Yes, it will, because you're inheriting, cars inheriting from vehicle. If I had a class parking garage, should it inherit from the class vehicle? No, a parking garage is not a vehicle. Don't even try it. Don't even try. If there's an article in MLive about one of you hammering wheels into a parking garage, don't even try it. Daniel, yes.
What about like those 18-wheelers that like load cars on them?
Oh my gosh. And then in one of the Gone in 60 Seconds movies, there's always a car that like drives over it. Or no, one of the Taken movies, the car drives over the ramp or something. In Java, how many parents can a class have? One. You can have one direct parent, but you might indirectly have some other parents. Sorry, I didn't hear it. Nope. All right. There's one last thing before you pack up. It says the student class can also inherit from the class person, just like employee and student. Employee and customer, because a student is a type of person. What do you need? Okay, never mind. We'll do this tomorrow. We'll skip it. We'll do it tomorrow. We'll do it live. We'll do it tomorrow. All right. Remember that I'm a good person. Didn't say anything that was offensive to anybody in this video.